Hi, I'm Riley, and this is Emma. She's my guest for this week. I'm going to be live explaining to her because that's what these videos are all about. She's not a physics major or a chem major or STEM of any kind. So the last time she did physics was in high school.
Yeah.
So we're going to explain it to her. Let's get started. So here's our question. And it says, it's your birthday. So it's your birthday. And we're going to celebrate by making you jump off of a bridge. And that's 100 meters tall over a raging river and with a 30-meter long bungee cord attached to your harness.
Okay.
And we're given that the spring constant of the cord is 40 newtons per meter, and your mass is going to be 80 kilograms for today. And after long hesitation, you jump off the bridge. You dive off, sorry.
Wow.
And yeah, we're asked to find how far above the water are you when the cord reaches its maximum elongation. So what does all that mean, right? Right.
I don't know.
Well, we have a nice little diagram. So here's us. That's me, and that's Emma. And this is our bridge that we're standing on. And then here, it's 100 meters long. And then here's our 30-meter rope. And later on, we'll show you something else. But here, let's just talk about the learning objectives for a minute. Is going to be introducing potential energy and then the conservation of energy. So first of all, here is what potential energy is: the energy that's stored inside of you. So you're at the top, here you are at the top of this little bridge, and you have all this potential energy that all this energy that could potentially be used when you jump off, but you haven't yet. So you got a lot of potential energy. And in order to find that, we just multiply your mass times gravity times height. And I wrote down everything that was given in the problem. So the height of the bridge, the length of the bungee cord, yes, thank you, the spring constant, and your mass. But max elongation, you might be thinking, what's that?
I don't know.
So it's basically the elastic limit of the spring. So like the max, it can stretchy. Yes, exactly, the stretchy. The max stretchy. And that's going to be given by 100 meters because that's like the length of the bridge plus x. We don't know what x is yet because we need to find x. And we use this equation from above. I don't know why I swapped the P and the E, but this is still potential energy. This is totally written wrong. So anyway, you were given this times 9.8 times what we have for max elongation right now. We don't really know it, but we're just subbing it in. And then if you multiply this out, you're going to get 78,400 plus 7884x. And yeah, that's great. We have a potential energy, but keep in mind, we're asked the max stretchiness, as you said. And how do we get the max stretchiness if there's no kinetic energy? Because kinetic energy and potential energy, they go hand in hand. Mm-hmm. Energy is conserved, conservation of energy. So there has to be some kinetic energy because you jumped off and now the stretchiness is at its max.
Yeah.
When right here it was at its min. So we have our kinetic energy, which is also written backwards, Riley, which is 1/2 k, which in this case is the spring constant, x squared. So then we put in spring constant times 1/2 and then x squared, and we get this. So then here I put them equal to each other because, conservation. Potential energy is going to be equal to maximum energy. Or together, they're going to equal 0.
Mm-hmm. Okay.
Yeah. So so this is our equation, and since we have a square, I wrote it this way, just disregard this line. That's why I wrote oops. But we need to use a quadratic formula because we have an x squared and an x, and then like a constant, all equal to 0. And if we use the quadratic formula, we find that x is equal to 85.21 meters. So, yay, we found x. Now we can plug it into our max elongation formula that we had before. And in order to find our max elongation, we have to take multiple things into consideration. So we have our 100 meters, which is the bridge, because it's asked from the water. So the reason we have the 100 meters is because it was asked like how far above the water, above. And then we have 30 meters because that's how long our bungee is. So that's kind of important. And then plus the 30 meters plus how much it's elongated, which was 85.2. We just found that. Mm-hmm. So then here's you when we got negative 15.21 meters. So that means, look at you.
I'm in the water?
You're in the water, 15.21 meters. Yeah, because the maximum elongation happened to be negative. So you're actually in the water.
Well, that's a bad birthday.
Yeah, it was. But, there you go. I hope this made sense to you.
They did.
And I hope your birthday's better next year. Thank you and have a nice, great winter break.